Immanentizing the Web3 platform. Yeah, hard word, right? Huh. Using IPFS browser integrations to turn the biggest ship. So I'll give it up for Dietrich.
I had no idea that we were going to be on an actual ship, on a boat, when I made this title up. But it is fortuitous. Now, will the slides work? Let's try. Maybe I can't turn the ship. I turned the ship too fast. There, yes. So I work at Protocol Labs. My name is Dietrich. I work on IPFS-related things. For over a decade, before joining Protocol Labs, I worked at Mozilla. So I shipped my first feature in Firefox 2, 2006. It was a feature to restore all your tabs and things when the browser crashed, because it crashed a lot. It was super fun, and I got to spend over a decade learning about how the web is made, learning about how browsers are made, and then when I wanted to change how the web is made, doing this work at Protocol Labs equipped me very well for understanding the lay of the land, who the people, who the organizations were, how change is made. Protocol Labs takes a very long view of this type of change, which makes it a good home for doing this kind of work. If you have not heard of Protocol Labs, you may have heard some of the projects we work on. IPFS, the Interplanetary File System, which I'll talk mostly about today. libp2p, a transport-agnostic peer-to-peer toolkit. Many technologies, not just IPFS, are made with libp2p. And Filecoin, which is for archiving data and files for the very long term for humanity. IPFS is what I work on primarily. IPFS is a content-at-addressed P2P file distribution system. So this means that instead of like the regular web, where you would address something by its location, like the server name, the domain name, path to a file, on IPFS, you address things by the identity of the contents, by basically like the hash generated, for the most part, simplified from the bits that comprise the file. So if you have a photo and you change one pixel in that photo, the two files are now, that one file is now two different addresses for the same file. You may be familiar with IPFS if you've ever worked with NFTs. This audience, I'm sure you're probably very familiar with these things, but worth covering quickly. These are some of the people that I work with on the browsers and platforms team. We're a very small group that work on integrating IPFS into places that it is not typically. So working on browsers, but also a number of other places. So we have folks that work on this guy smiling up in the really big in the front actually has been working on trying to get IPFS into FFmpeg and curl, which has been a very interesting journey and super hard and really challenging, but working with open source toolkits and libraries to be able to get IPFS integrated into all these places where it normally might not be. Some of the groups that we work with here, everything from browser integrations to privacy-oriented messengers to operating systems and things like that. This is a very old copy of the file. Wow. It has some of these slides, though. Hey, did you, well, I'll just take it and see how it goes. I don't remember what slides were in here from 2 weeks ago, but we'll find out. One of the challenges with IPFS integration in browsers is that in Web 2 is a very particular architecture. This architecture has grown to be, billions of people using the web architecture, web platform every day, to very small number of entities that actually make decisions around how this platform is designed. HTTP, JavaScript, CSS, the DOM, everything up and down the web platform stack is, I wouldn't say centralized, but it's the product of a very small group of people, especially when you think about the implementations and the vendors that are doing it. For 4 billion people using this platform, that a fairly small number of people are involved in actually making decisions about. For browser market share, very, very particular domination of one particular web rendering engine, which is Blink. WebKit, a second, but pretty far behind, and then any other web rendering engine, very, very far behind that. When we think about the developers that we're actually trying to change the minds of, that we actually need to address the needs of, over 20 million developers, maybe 30 actually by this point. And Web3, still very, very small, but we're getting there. So for this team and our approach to changing this web, to turning this really big ship, we have a thesis, which is basically that actually integrating IPFS into the web platform itself ends up being the only way that we have an unfair advantage and actually have some leverage against very, very large organizations that are making decisions about these technologies. The ubiquity of the web means that if we can change the web itself, we don't have to convince all of these hundreds of millions and even billions of people to change their behavior as much, because those web rendering engines actually get shipped out to those operating systems and platforms that we would otherwise want to change. If we can create enough, just enough of a wedge of integration and implementation inside things like the web platform itself, those then get propagated and percolated out to all the places that web rendering engines actually get deployed. So every operating system, whether it's mobile, whether it's desktop, and we believe that these things will mutually reinforce each other, and we can actually accelerate the integration of these technologies. But it's complicated. There's a lot of organizations and places where decisions are made around the adoption of these technologies. Some of these places are like the W3C, the IETF, where technology decisions are made in groups of people that are pretty focused over very long periods of time to be able to make this change. There are some myths around these things that they can be slow, they can be bureaucratic. It's true to some extent, but also with the right leverage, the right approach, you can actually make technology change pretty quickly. So one of those myths is that in Web3, we don't actually need to do any of this, and we could just build our technology. It will be so amazing that the other billions of people will actually just change their behavior and use our stuff immediately, which is obviously not the case. It's very, very long period of change to be able to change the web itself and to be able to change the technology decision-making behavior of developers, let alone the actual companies that are shipping things and user behavior as well. So oftentimes, the people that are in these decision-making fora, like the W3C, are the same people that we want to be able to make decisions in our favor at Chromium and in Gecko and in WebKit and all these other places. So they end up being the same parties ultimately in the end. So it's in our best interest to be able to participate in those decision-making fora. This is a view of how long it took for a CSS grid to be first implemented in Internet Explorer, oddly enough, and eventually adopted across all of the major browser rendering engines. It takes a really long time to make change in these places. And this isn't even something like a security model or a privacy paradigm. This is for layout on the web, which everybody knows has been broken for a very long time. It's very difficult to deal with. But eventually we have CSS grid. Things are a little bit better now. But even for something as uncontroversial as laying things out on a page, the pace of change can be really small. However, one of the things that we learned when CSS Grid was ultimately adopted was that when a coordinated group of people with a shared interests actually get together and decide to implement something and coordinate that release in a short period of time, you can actually rapidly accelerate the adoption of that technology. And you can look at sites like caniuse.com to be able to see what different versions of what rendering engines support which technologies. And we look at these as a way to be able to understand how much of that technology has been shipped and whether developers can actually choose it. And in the case of CSS Grid, developers and designers, they can't use CSS Grid if it is not in the places where they need to deploy their applications to. And we have the same challenge when we're shipping Web3 technologies. It's really hard to get adoption when you have to use centralized on-ramps to be able to get to decentralized systems and networks. And that's one of the reasons why we work on changing the browser platforms itself, slowly getting adoption and integration. So another one of the challenges is that when we talk about things that seem pretty normal in a room like this and at a conference like this is what we sound like in places like the W3C. And if you followed along with like the DIG core adoption, like there's a lot of hostility and skepticism and a lot of friction in getting anything related to decentralized technologies that are not HTTP actually agreed to and turned into a standard at these standards bodies. So it can be really challenging. One example is that we wanted to add the safe listing, basically like there's an API in the web called Register Protocol Handler, and you can tell the browser, hey, with this JavaScript API, I want you to do something, like call this JavaScript or whatever, when you encounter the IPFS : / protocol. We wanted to change that Register Protocol Handler across all browsers to be able to accept IPFS, but we actually added, this is the newer one, initially we came out with like Bitcoin, Ethereum, SSB, DAT, IPFS, IPNS, like we just added a bunch of stuff and said, hey, can you just whitelist these protocols? And we went through this process. where we talk to the different rendering engines, and some are more, you have to go file bugs for each one. We actually partnered with a company called Ayala that has commit privileges across Gecko, WebKit, and Blink, and we worked with them. Well, they wouldn't register the protocols unless they were actually registered. Those schemes were registered with Ayala, so we had to go to IANA, register those schemes. That took another couple of months. We had to go to all these different distributed projects. Like, we actually went to the Scuttlebutt people and said, hey, mind if we do this? And they were like, we have no leader. I guess so, or not, up to you. We went to the DAC community, and they were like, yeah, sure, do it. We eventually got those whitelisted, allow listed, and then we put them at the WG. We finally go back to Mozilla, who'd actually added these schemes and then removed them again. And they said, well, we're only going to add ones that have been standardized, which leaves us in a weird place, because we can't add anything that hasn't been standardized, but we can't implement anything in our browser. So we end up in a situation where I'm not sure that we're getting the whole story here, because there's a lot of skepticism around these technologies generally. But there are a lot of, there's a lot of barriers involved. And in order to be able to cross that chasm and get these technologies implemented into these places, we've kind of moved along. We want these people to be on our side, like I said before. We want to have a relationship. We need credibility. We need to get our technologies into these channels, deployed out to end users, so we don't have to keep jumping through all these centralized hoops. So we did join the W3C as Protocol Labs. We participate there. We participate in the IETF for a couple of our technologies as well. We have folks that are working on things like HTTP3, and then a couple of different other organizations that we participate in. We need to be able to do this in order to be able to make these, at least build some credibility there. But at the same time, standards are not, they often are written after the fact of implementation. In order to be able to get to the point where those standards are adopted, you need to have some adoption already. You need to get to the point where there are multiple interoperable implementations of your technology. So this is kind of a map of how far we've gotten at this point. We're about to get to IPFS, well, more reasonable IPFS handling native in Chromium, and I'll talk about that in a sec. But as you can tell from this, there's a lot of work to be done. It's very, very challenging to be able to get any ground gains in the implementation of these things. Opera was first. They initially had IPFS scheme handling, and they redirected to a gateway. They did that across all their browsers. Firefox, I worked on that for a long time. Not really a lot of interest so far in this. They actually safe listed the IPFS protocol just for handlers and then removed it. So there's still really a lot of work to go there, and they're one of the biggest objectors to the DID specification at the W3C. They objected to the group even being chartered 4 years ago. So there's really a lot of, it's an uphill battle there. Apple, slow going. It's going to be a long slog. There's no incentive for them to change or adopt any of this. We're going to have to probably wait until we have much larger adoption in many other places to be able to have the environmental pressure required. Brave has been fantastic. I know some of those folks because they're also from Mozilla. We got a full IPFS node early last year, and you can flip that on in Brave, and a bunch of new features are coming soon around things like automatically archiving your NFTs that you have to be able to make sure that not only that, you can use Brave to be able to store and archive data and publish to IPFS to be able to keep not just yours, but any NFTs safe that you browse, which is kind of interesting. We're going to see a lot of new stuff there as well. Chromium is definitely the most challenging. So they've actually been reviewing our patches pretty quickly. We get good turnaround. We've been focusing not on IPFS-specific things, but on interoperability and compatibility across browsers. So we fixed a bunch of things around the local host security model. So if you want to be able to have your browser talk to a local IPFS node or a local node of any kind or a local light client of some kind, you need to be able to communicate from a web page to localhost. And there was a lot of compatibility issues around that specific security model about how browsers actually implement it. So we gained some ground there, and we got a bunch of patches landed. One of the bigger challenges when you think about native integration of something like IPFS or anything not HTTP at all in a browser is that up and down that browser security stack and implementation and rendering engine, all the way out to graphics pipeline, out to permissions checks, data storage, everything is pretty HTTP-centric. everything is oriented around the security model of HTTP and how it operates. So we've had a project going with Ayala to refactor the Chromium code base over this last probably year and a half to be able to actually support non-HTTP protocols more readily. It doesn't go all the way up and down the network stack. It doesn't go all the way up to every little nook and cranny of the rendering engine, but it goes a lot farther than it did before. This is one of the key things that is not IPFS specific necessarily, but it helps this entire space when anyone wants to add something to Chromium, the open source code base that Chrome and Brave and Opera and Edge are all built on, not just IPFS. So we think this is going to be pretty impactful. We're going to announce the most recent changes around scheme handling probably in the next couple of weeks in conjunction with Ayala. This should make it really a lot easier for Brave, for Edge, for Opera to add things without having to add a bunch of custom code to Chromium. And we're not getting necessarily explicit signals from Chrome saying that we would do this, or they would implement anything like this. But what we are getting is really a lot of appreciation and cooperation from the Chromium community around these types of refactorings. So there's definitely interest and awareness in this work and an understanding of why it matters. IPFS Companion is a browser extension that's available all over the place. Now, one of the challenges with extensions is, if you haven't heard of it, there's a thing called Manifest v3. It's a new format of browser extension that is radically reducing the surface area of what extensions can do. And it's problematic in a couple of ways. I think initially, we thought that browser extensions might be a route to be able to get non-HTTP protocol support inside browsers. However, with Manifest v3 and really reducing what you can actually do inside of a browser extension, it's become ever more important now to invest in non-HTTP protocol support inside the rendering engines themselves, because you can't do nearly as much with Manifest v3. Basically, every other browser vendor is also adopting this, even though they don't have to. Mozilla adopts Manifest v3, but does have a superset of APIs that it adds that allows you to do other things like ad blocking, a little bit more network functionality. But really, all browser vendors are kind of locking down extension space, because for them, it's a UX issue. It's one of the biggest battles I fought when I was at Mozilla was the fact that browser extensions make browsers very, very slow. In browsers, you have to be very careful about the code you land. Lots of code that I landed got backed out because it made the browser slower. And I wasn't able to land it and merge that code until I didn't reduce things like browser startup time, for example. But browser extensions have the ability to really slow down browsers. So it's complicated in that regard. They're also a security problem. So browser extensions can do all kinds of things. They have elevated privileges that a web page can't. So they exist outside of the web sandbox and therefore are a threat. And one of the big changes in Manifest v3 is that it really moves a lot of this code to be treated more like a regular web page, which reduces what you can do with it, but also is a trade-off for safety and user experience from the vendor's point of view. But from the things that we want to do, like change the nature of the web itself, it's very problematic. So what's next? A couple of different things. We're going to see deeper browser integration or protocol support and integration. We have this initial code in Chromium that allows us to more easily register non-HTTP protocols and schemes. But one of the next things we're going to do is actually do a native integration. So instead of just having IPFS : / in Chromium be able to redirect to a IPFS gateway somewhere, we're actually going to have Rust IPFS in there as a native implementation sitting inside the Chromium network stack. This is probably going to be a longer project, but it's going to be pretty interesting. One thing we're seeing is a bunch of different, boutique browsers pop up. So things like Puma and Bloop and all kinds of not really Web3 oriented ones. But lots of people experimenting with browsers as a business model, as an alternative to kind of the mainstay browsers that you've all heard of. That's really interesting. We're also experimenting with new architectural approaches to how IPFS can be implemented. Right now, it does require a whole bunch of listening sockets to be able to have a P2P connection. However, for something like mobile, that's not really reasonable. We need an implementation of IPFS that is along that centralization, decentralization spectrum, at least less centralized. And maybe that looks like racing a bunch of HTTP gateways to see which one responds comes first. Maybe it means using local OS mobile network stacks in a more concerted way that aligns with mobile connectivity models that telcos have today. But it can't look like opening up 700 TCP connections on a mobile phone. So a lot of experimentation with that. We are hiring. If you're interested in doing work around standards, implementation and rendering engines, definitely find me and talk to me. These people in the face of this enemy-frenemy situation are still smiling for the most part, but I think the look on our face oftentimes in these type of negotiations end up like this. It's long, slow, difficult work to be able to change the direction of the entire ship itself, but it's super interesting, and we've made some gains, and hopefully the entire space of crypto, blockchain, and Web3 will be able to benefit from that. Thanks.
Thank you, Dietrich. I think we have time for 2 or 3 questions, maybe. Is there a raised hand or just a yaw? No? No. It is a raised hand, yes.
Hello, thanks, great presentation. I have an unrelated question. When is the Protocol Labs week in Portugal?
Yes, I think it's the IPFS camp is October 28th through 30th, and then Filecoin Lisbon is right after that. And then there's also a libp2p day that I think is October 30th.
Okay, thanks.
So basically that whole week at the end of October.
Awesome. Thanks.
Yep.
There's another question right there.
My question concerns that I used to work on Swarm, which is also decentralized file storage, and we were this short of giving up and saying we're just going to launch our own browser, like the Swarm browser bundle. And the problem with us is we didn't just want to talk to Swarm nodes, we also needed to talk to Ethereum nodes, and now would be Gnosis chain and a whole bunch of other things. So where in your work, how much of this is IPFS, IPNS specific, and how much could be used to open up browsers for a whole, much wider range of peer-to-peer sources of data and info?
Yeah, that's a fantastic question, and I think grounded, I come from years and years working in Web 2, and only recently in this last few years have been focused on IPFS, and really after kind of hitting that wall also of being like, even being in browser world, I couldn't change browser world, and really had to step back from that. And one of the approaches that we've grounded our work in is thinking about non-HTTP first. How do we get to the point where, and really, I guess, at a higher level strategy, try to change that world slowly, while also implementing in parallel with things like Brave. So like I said before, a standard isn't like a group of people build that standard and then follow along and everybody implements, but more like some success is gained by folks that are shooting forward. So we take advantage of vendors like Brave that are really interested in pushing on the limits of what the web can do and adding some of these features, and hopefully using that as a leader to be able to open up the credibility and the reality, making it seem more real in the nature of those conversations with other vendors. But even all of that still grounded in a not just IPFS, but in places like Chromium, really focusing on not HTTP. And then slowly showing what we can do with IPFS in that space that we open up of non-HTTP protocol place. So, but
yeah. Our dream had been a browser that could only talk BZZ. Would completely not be allowed to open any HTTPS connection because that makes it impossible to put tracking code in any DApp.
Right. But that's a design decision, right? And that's something that from thinking about your users, if you, yeah. But tilting at those windmills are what lead to reverberations all the way back as people say, okay, well, maybe we can't go all the way, but we can do a little bit, and then a little bit, and a little bit. So, I always encourage, some of these, alt browsers and boutique browsers that we're seeing, I encourage them actually to take that route. If you're going to do that experiment, go all the way. Prove that concept. Show it is possible, especially with a community of users that may have dire critical need of that use case. The I cannot be tracked is a valid use case. And there are some people that are absolutely willing, actually have to make that trade-off in what they choose and use. So you kind of got to have both.
All right. Thank you very much, Dietrich.
Thanks, everybody.
And